Okay, in this video, we're going to take a look at how a computer can handle working with vectors and matrices. And I'm going to look at using a popular programming language called Python and take a look at some variations on the examples from the notes. So just first up, before anything, I'm using Google Colab, which is a online notebook in which you can write in text and format mathematical text to get these vectors and matrices here, as well as insert code. So it's really helpful if you have like things you have to write, and they can be non-mathematical as well, but you also want to insert code to analyze what it is you're talking about. So here in the example that we looked at, the first example, we had two vectors, v and w. V was -1, 3, w was -3, 0. So the first thing I want to do in this notebook here is I'm going to use a Python library called NumPy, which is very good at numerical calculations, especially ones that would normally take several thousands of hours if we were to do these by hand. NumPy is very efficient at getting calculations very fast. It's similar to other programming languages like MATLAB, which if you go off to college, you might learn in an engineering program. But that is software that you have to purchase, and Python is free. So I'm going to start by importing that library, and I believe I already did that, so it should be good. And in NumPy, you can abbreviate it, so you don't have to type out the word NumPy every time. This is called an alias, where you import NumPy as something shorter, so you don't have to type this out. So NP. So I want to set vector v to be -1, 3. And there's a couple options you have with vectors in NumPy. If you want to do just a traditional vector, you can use the numpy.array, A-R-R-A-Y, and then put your vector inside the bracket. So -1, 3 for v, and then -3, 0 for w. So I'm going to run this so it stores it. And now I can calculate vector v plus vector w, which should give us the -4 and the 3. So if we calculate this, we get -4, 3, as expected. If we calculate -2 times vector v, that should take each of these components of vector v, the -1 and the 3, and multiply them by -2. So that should give us a 2 and a -6. And lo and behold, it does give us 2 and -6. Now, if we want to work with matrices, such as the ones we looked at towards the end of the notes, NumPy also has what's known as its matrix library. And this looks kind of weird, but it's just a formatting to make it a little easier to type. You could actually type all this on one line, but just to kind of make it a little bit easier to see and kind of make it look the way it does as we normally write it. So we get that by typing in numpy.matrix and then a parenthesis and a square bracket, and the notebook will automatically close the bracket and the parenthesis. And then we put each row inside brackets themselves. So bracket -2, comma 3, and then close the bracket, and then a comma is going to indicate, okay, we're done with that row. Now we go on to the next row, which is 0, 4. And we don't need another comma because there's no more rows after it. So matrix B, very similar. Bracket 4, comma -3. The comma after the bracket, this right bracket, indicates we have another row we want to type in, which is -2, -1. Again, notice the parenthesis bracket for NumPy matrix, bracket parenthesis. It closes it up. Very easy to forget, especially if you have the brackets here and here. So these ones just indicate a row. And C is same thing, -7, 6, -1 in the first row. And then in the second row, 0, 4, -4. So let's go ahead and run this cell. So it recognizes matrix A, matrix B, and matrix C. And now if we want to add matrix A and matrix B together, we can just run this, just typing in A plus B. You don't need the space. I just like to put the space because it's easier to read. And hit enter, and we get 2, 0, -2, and 3, which is -2 plus 4 is 2, 0 plus -2 is -2, so that's that first column. And then 3 plus -3 is 0, 4 plus -1 is 3, and that's where we get this second column. So B plus A, we saw, should give us the exact same answer because matrix addition is commutative. It does not matter what order we add, and lo and behold, we get the exact same results, as we should, as was expected. We can also subtract matrices, so we get negative 6, 2 in our first column and 6, 5 in our second. Again, negative 2 minus 4 is negative 6. 0 minus negative 2 is 0 plus 2, which is 2. And then we get that second column as well. Finally, we can do scalar multiplication for a matrix. So it's going to take each of the elements in matrix C and multiply them by 7. So our first column should be negative 49, 0. And if we run that, we in fact do get that for our first column, negative 49, 0. And then our other columns are multiplied by 7 as well. So again, every element in the matrix will get multiplied by that scalar. So, all right, that about does it for this video. Thanks for watching. Hope you enjoyed it. I'll see you next time.